All right, here we go. 1.4, geometric series. Students will be able to find the sums of geometric series and find specific terms of geometric series. What is a geometric series? This is simply the sum of the terms of a geometric sequence. And in case you don't know what a sequence is, it's literally just like a pattern of numbers. That's a sequence. And there's two different kinds. Well, there's probably several kinds, but there's two primary kinds, arithmetic and geometric. So we're only caring about geometric. What geometric means is that you're multiplying by a common number each time. Let me just give you a little side example up here. Like, let's just say I started with the number 1, and then I got 2, and then I got 4, and then I got 8. You could see what's happening, right? Every time I'm multiplying by 2, when you multiply by a common ratio, that is a geometric sequence. The series is just the sum of all those numbers added up. Now, couple things I want to make sure you know before we move on. There's some language in here that you may not be familiar with. So I'm going to write it over here, just some notes, just so you know what I'm talking about as I talk about it. When you see a sub 1, that just means the first term. N, this means the number of terms. So are there 5 terms in the sequence? Are there 10, 20? What? How many terms are there? R, this equals the common ratio. This is like what we're multiplying by. So my example up here, the first term was 1, the number of terms was 4, and the common ratio was 2. All right, a couple other things you're going to want to know. S sub n means the sum of that sequence, also known as the series, for however many terms there are. So like if they said S sum 8, then I would want the first 8 added up, and so on. All right, so let's get into this. We got this formula here. Now that we know what these terms mean, I think we can use this formula to answer their question. So it says evaluate the sequence by using the formula, and then they give us the sequence. What I want you to do first is to fill in these critical parts. We need to know these before we can do this. Here's the formula. So let's plug in each part. Okay, so what is a sub 1? Well, in this situation, a sub 1 is 3. What is n? N is the number of terms. 1, 2, 3, 4, 5, 6. So n is 6. What is R? R is a common ratio. What does it look like is happening every time? Looks like they're multiplying by 2 every single time. So R is 2. Now they want me to figure out the sum. So if I go over here, I have this formula up here. This is how you figure out the sum. So let's plug everything in. A sub 1 is 3. Then I'm going to do 1 minus my R, which is 2, to the n, which is 6. Put that over 1 minus my R, which is 2. And then we just simplify. This formula will give us the sum of all these numbers added up. Now, of course, we could just add these all up individually, but what we're trying to do here is, even when the sequence is very complicated, we can still get the sum very easily. So we're learning a system that will apply to even more complicated problems. So the first thing I'm seeing here is I need to know what 2 to the 6 is. Well, 2 to the 6 is 64. Feel free to use a calculator for crazy things like that. But maybe that's when you have memorized. I kind of memorize a lot of the 2s because you go to 4, then you go to 8, then you go to 16, then 32, then 64. So that's 64. So we have 3 times 1 minus 64 over negative 1. Which means, I'm going to come to the right since I have some space. I have 3 times negative 63 over negative 1, which means these negatives can cancel out. So really I just have 3 times 63, which is 189. And there's my sum. I'm done. Okay, that's how you do that type of problem. You identify your pieces, your first term, your number of terms, and your ratio. Plug it in this formula and simplify. So I want you to go ahead and try practice one on your own, and then unpause the video when you're ready to check your work. Okay, hopefully you start off by finding that your first term is 4. Your n is a little bit confusing here. You might not have known that, but this is your n. They're telling you the sum of the first 10 numbers in the sequence. So we don't actually see them all, but we know that we're going to the 10th term, and we're going to add them all up. And then we could tell what the common ratio is, because we could say, well, they're multiplying by 3 to get to 12, they're multiplying by 3 to get to 36, therefore the common ratio is 3. Plug that all into your formula. I have my first term, 1 minus my common ratio to the 10th power, because I'm doing 10 terms, all over 1 minus my common ratio. And then you're just doing some basic math. Might need a calculator to work out some of these bigger numbers, but that's totally fine. And you end up with 118,096. That's it, okay? But let's move on and see how it can get a little bit more complicated. Now we got this. This is called sigma notation. And I want to talk about sigma notation. This is kind of how it's always going to be set up. Usually it's going to start with n equals 1. It's possible for them to put n equals 0. I don't think that you'll see that here. And then the number that you're going to start with ends up there. So they're saying start with 1, end with whatever number shows up here. Like here they put a 6, but just know the number that the number of terms you're going to end with will be on top. And then what they have here is an explicit formula for you to get any single term. So you have a sub 1 times your common ratio to n minus 1. This is actually the equation for a sub n, meaning we can find any term with this equation. So if I wanted to find the 5th term, I'd plug a 5 in for n. 5 minus 1 is 4. Take my common ratio, raise it to the 4th power, times it by my first term, and boom, I have the 5th term. That's how that works. So I wanted you to kind of see what this means. This means, this is simply just a sigma notation, just is our special math notation for meaning that we want the sum of all the terms from 1 to whatever number we pick. So what does this thing mean? It means we want all the sum of all the terms from 1 to 6. Now, I'm going to kind of like spell out exactly what this means for you. So we could actually find each of these terms, and I'm going to kind of walk you through this. So like the first term here would be if I plug in a 1. Well, if I plug in a 1, I get a 0. Anything 0 power is 1, so the first term is simply 5. What would the second term be? Well, hopefully you can look at this and you can see the common ratio is 2. So I think we're just multiplying by 2. So I think the answer is going to be 10, but let's just work it out. If I plugged in a 2 for n, 2 minus 1 is 1. 2 to the 1 power is 2, and 2 times 5 is 10. And so you could kind of tell what we're doing here. We're just multiplying by 2 every time. And so you can kind of just skip and go ahead. But let's say you weren't sure. Let's test out my last one. A sub 6. A sub 6 would be like saying, I'm going to do it in blue over here. It would be 5 times 2 to the 6 minus 1. Well, 6 minus 1 is 5. 2 to the 5th is 32, so I have 5 times 32. If you do 5 times 32, what do you get? Well, you get 160. That's it. Okay, so this part here is just telling you which term to do. All right, but this means add them all up. Add them all up from the first term to the 6th term. So yeah, we have all the terms now. I could just add these all up, but what we want to do is we want to practice using our formula, right? So if I'm going to add them all up, let's make sure I note all the things that I need. Well, I need a sub 1, which in this situation we already found out is 5. I need the n value, which they give me up here is 6. And I need the r value, which will always be this number right here. Boom. And now I can just plug this into my formula. And I can say that my sum of the first 6 numbers, that's an S, by the way. My S's and 5s tend to look alike. And I'm going to put 5 for a sub 1, parentheses, 1 minus 2 to the 6th power. I'm just using that formula up top, over 1 minus 2. And we're just going to work this out. So 2 to the 6th, that's still 64. So I have 5 times 1 minus 64 over negative 1, which is the same thing as 5 times negative 63 over negative 1. And yeah, my negatives cancel out, so I really just have 5 times 63. And 5 times 63 is 315. And there's my answer. Now, could you have just found all the terms and added them all up? Yeah, that's totally fine. But we're trying to practice how to use this formula, right? So what I want you to do on practice 2 here is use the formula. By formula, I mean this guy. Figure out what your a sub 1 is, what your common ratio is, and yes, it's negative in this situation, and how many terms you're going to be adding up, and use the formula to figure it out. You don't need to go through and list all the values. I'm just showing you kind of behind the scenes what it's doing. So go ahead, try that, and then remember to unpause the video when you're ready to check your work. Okay, here's what you should have found. You should have found your core values here, plug that into your formula, work it all out. You should have got negative 364. But what I'd like to do is kind of talk about this problem just a little bit more. I want to talk about what the actual series is, or the sequence is. So we know the first number is 2. If we multiply that by negative 3, we would get negative 6. If we multiply that by negative 3, we get positive 18, then negative 54, then positive 162, and then negative 486. And the series gets interesting here because depending on whether or not you add up to an even number or an odd number of terms, changes whether or not it's negative or positive. And that makes sense, right? At an odd number, we have only positive values here, so we get a positive answer of 2. Once we get an even number, we have a negative and a positive, and the negative will always be bigger, so we're going to end up with a negative number. Odd, now we have a bigger positive, so we're going to have back to the positive sum, then a negative sum, then a positive sum, then a negative sum. So if they asked us to go to the 7th term, we would end up with a positive number instead of a negative. Because you could kind of imagine, like, if you were to graph this out, the sum would go positive, then negative, then positive, then negative, then positive, then negative, and so on and so on. So it's bouncing back and forth. All right, let's go to the next page. So this gets a little bit more interesting. It says, find the sum of the geometric series for which a sub 1 equals 15,625. We know that the nth term, whatever n is, we don't know what n is negative 5, and r equals negative 1/5. So remember, in order to do our special formula, we need a sub 1, right? But we also need to know what n is, and we don't know what that is yet. But we do, and we also need to know what r is, and we do know that. So to move on, we really need to figure out what the n value is. Now, there's a few different ways we can do this. I'm going to come over here and just kind of write down some of the information. So I'm just going to copy down that a sub 1 is 15,625. So let's think about how we could do this. We could kind of do this like the old-fashioned way, right? If you think about it, like what I would say, just like literally list out the terms. And so let's try that. Let me zoom in here so I have plenty of space. So the first term would be 15,625. I'm gonna do like a semicolon because I don't want to confuse the comma on that. And the next term would be whatever I get when I multiply that by negative 1/5, my common ratio, right? So the next term would be negative 3,125. And then if I multiply that by negative 1/5, I get 625. And then if I multiply that by negative 1/5, I get negative 125. And if I multiply that by negative 1/5, I get 25. And then finally, if I multiply that by negative 1/5, I get negative 5. Remember, they gave us this hint way over here. They said a sum is negative 5, and we just found negative 5. So what term did it take for us to get to? Well, let's just count them, right? 1, 2, 3, 4, 5, 6. So n is 6. Now that's with listing out all the terms. Like I said, that's like the old-fashioned way of doing it. But what if there's like, just a bunch of terms? Then what could we do? Well, that's where that explicit formula that I was talking about earlier would help us out quite a bit. So on the previous page, I said you could find any term by saying a sub n equals a sub 1 times r to the n minus 1. And let's think about what we know here. We do know that a sub of 5, a sub n, for any n value, we don't know it yet. I mean, actually we do, but let's pretend like we don't, is negative 5. So I'm going to say, well, that's negative 5. We know that a sub 1 is 15625. We know that the r is negative 1/5, and we do not know the n minus 1. Let's take a zoom in on this equation and think about this. This is a solvable equation. It's going to take a little bit of work, but it is a solvable equation. I'm trying to solve for n, and I have only values here, so I can do that. what I'm going to do first is I'm going to divide both sides by 15,625. And I'm not going to, over here on the left, I'm not going to get a calculator out really. I mean, I can, but I'm not going to get a decimal. I'd rather have a fraction. You'll see why in a while here. So when I reduce that, I end up with, I need to go where I have some space. I would end up with negative 1 over 3,125 equals negative 1/5, because that's my common ratio, to the n minus 1. So now what I need to do is to solve for n, I need these bases to match. So I need to figure out how I can write 3,125 as 5 to some exponent. And for this, you might just need a calculator, but you can just play with it a little bit. Basically, you're asking yourself this question. You're saying 5 to what power equals 3,125? And that's really all you have to worry about, because you already have a negative 1 on top. So that's not going to really change. What's going to change is this value. So how can I rewrite this? So if I went to my calculator, I'm going to just start with like 5 to the third. I get 125. So I'm going to do 5 to the fourth, 625. I'm going to keep going, 5 to the fifth, and I get 3,125. So I just found out, just from my calculator, that 5 to the fifth is 3,125. So that means I can rewrite this equation as negative 1 over 5 to the fifth equals negative 1 over 5 to the n minus 1. Well, this is what's nice about the negative 1 here. A negative 1 to an odd exponent is still going to equal negative 1. So really this is like negative 1 to the fifth. You could just assume that it's the same thing, because negative 1 to the fifth power still equals negative 1. So I'm going to put it like that, which means then I can think of it like this. Negative 1/5 to the fifth is the same thing as negative 1/5 to the n minus 1. Once your bases match, right, these match, I have exactly negative 1/5, exactly negative 1/5, then your exponents must match as well. And so you can rewrite this in a much simpler equation. You could just say, well, 5 must equal n minus 1, and I could add 1 to both sides, and I get that 6 equals n. All right, that was a lot of work. And for this problem, it was probably simpler to just count it out, right? That was simple. But what if the nth term isn't 6? What if it's like the 27th term or the 312th term or something like that? Then we're going to need an equation to do it. And so that's where this equation would come in handy, right? So this is the explicit form, and then this is the other equation. This is what we got when we plugged in our values. All right, all of that, though, all of that, I know this is super fun, was just to find out that the n is 6, right? Both times we got that the n is 6. So now that we know the n is 6, we can actually find the sum. So let's go back to our original formula that we had on the previous page. That means the sum of the 6 terms is going to be the first term, 15,625, times 1 minus negative 1/5, that's your common ratio, to the 6th power, because our n value is 6, all over 1 minus negative 1/5. All right. Once again, we find ourselves with a little tricky situation here, because we've got a lot of fractions, a lot of double negatives. So we want to give ourselves plenty of space so that we don't make any mistakes. So let's take a look at what we got going on here. First thing I notice right away is we have some double negatives down here, so let's just make that a plus. This is not a double negative because we have to raise it to the exponent first. So let's think about what this is. Well, anytime you have a negative to a even exponent, it becomes positive. So negative 1 to the 6th power is just positive 1. So I'm gonna rewrite all this. I got 1,5,6,2,5, 1 minus negative 1 to the 6th power is just 1. And then on the bottom, I have 5 to the 6th power, which, yeah, I'm going to want a calculator for because I don't know that. It's 15,625. All over, well, 1 plus 1/5. I mean, right, I'm doing 1 plus 1/5. You could think of that as 5/5 plus 1/5. So really, this is 6/5. Okay. Now, in order to do the subtraction, I need common denominators, but it's actually really easy. If you think about it, I'm just going to do 15,625 over 15,625. So this is kind of like what I'm going to think about here. I'm going to say I got 15,625 times 15625 over 15625. This is getting a little bit crazy. That's really just my 1. All I'm doing is rewriting my 1. Minus 1 over 15625, and then all of that is over 6/5. Okay, let's keep going. I have common denominator, so I can subtract. So I have 15625 times 15625 minus 1 is 15624 over 15625. And then all of this is over 6/5. Well, hopefully you see something beautiful here. I am multiplying by 15625 and I am dividing by 15625. And so these two numbers just cancel each other out. Thank goodness. Now, I'm also dividing by a fraction. So I have 15624 divided by this. But remember, when you're dividing by a fraction, that is the exact same thing as multiplying by its reciprocal. So I'm just going to multiply by 5/6. And what I'm going to do is I'm actually going to divide by, I'm going to take this big number and divide by 6 in my calculator because I can just reduce that first. So 15624 divided by 6 equals 2604. So I would think of this as 2604 times 5. In case you're confused on what I did there, it's a lot. But what I did is I just said, you know what? I can do this in any order I want because it's all just multiplication and division and they're equal operations. So I went ahead and did 15624 divided by 6 to get a smaller number to work with. And I'm going to multiply that by 5. And finally, I get an answer of 13,020. Fun, right? I know that's a lot. I think I gave you the harder problem, so don't stress. Definitely this example problem is harder than this example 4. But I want you to go ahead and try example 4 on your own. I think you have all the pieces that you need. Yeah. You do. But this one's just a little bit different. I'll let you try it, and if you get stuck, you can come back and watch the video on this. But it says find the first term. So now you're going to try to find that a sub 1. That's what you're trying to find, okay? But you're still going to use this same equation that we had on the first page because you know your sum, you know your n, and you know your r. So I'm going to let you see if you could figure that out and then unpause the video when you're ready to check your work. All right, so hopefully you started with the same equation. We have our total, our sum, which they gave us, equals the first term, which we don't know, times 1 minus our common ratio to the power of n, all over 1 minus the common ratio. All I had to do here is just simplify. I'm just simplifying. So simplifying, simplifying, simplifying until I get 3,280 times a sub 1 equals 39,360. Then I divide both sides by 3,280. And then I get that my first term is 12. Okay, if you're not sure what I did here, you could ask me about it in class, but I'm just plugging in the formula, simplifying, and then solving for a sub 1. All right, let's take a look at this last word problem. We'll talk about it together. It's not really a big deal. All you got to do is go through and try to find all your key pieces, okay? And then whatever's missing is probably what they're asking for. So let's read this question. A new sandwich shop is gaining in popularity. Every day since it opened, the number of customers is 10% more than the number of customers the day before. That's key. I just found something out. 10% more. I believe that's going to be my common ratio. Well, if I'm going to do 10% more, that means I have to think about starting with 1 plus 10%. And 1 plus 10% is like saying 1 plus 0.1. So it's 1.1. My common ratio is 1.1. All right, let's keep going. The total number of customers over the first 5 days is 1258. Well, if that's the first 5 days total, then we just found the total, right? The total number. And they told us first 5 days. So we also know, oops, I should do a different color. Let's do green. So we should also know that the n here is 5. Okay, so I know that S of n is 1258, and I know that n is 5. Looks like I don't know what a sub 1 is, do I? And what do they ask? How many customers were there on the first day? Well, that would be my first term, so that's a sub 1, so that's what I need to find. All right, well, let's just use the same formula we've been doing, where I say my sum, I'm going to rewrite the formula here so we can just kind of look at it as we go, equals the first term times 1 minus r to the n power all over 1 minus r. Well, for me, my sum is 1258 equals the first term, which I don't know, parentheses 1 minus the common ratio, which is 1.1, to the nth power, which is 5. All of that is 1 minus a common ratio of 1.1. Okay, the numbers may not look pretty, but we can definitely do this problem. It's nothing super crazy here that makes it impossible for us to do. We might end up with a weird number for the first day, like we might end up with a decimal answer, and that's okay. You know, a lot of math modeling isn't like perfect. It's just giving us a close number. So if we end up with something like there was 3.7 customers, we'll just say, yeah, there was about 4 customers the first day. Okay, so let's do this math. First thing I see I have to do is this 1.1 to the 5th. Let's use my calculator. 1.1 to the 5th is, I got a big old decimal, so I'm going to copy it all down. I got 1258 equals a sub 1, 1 minus 1.6101. And obviously 1 minus 1.1 is negative 0.1. All right, let's clean this part up, right? What's 1 minus that? I would get, I still have 1258 equals. By the way, I just want to point something out to you. In math, a lot of times you might see them just do this and just leave this area blank. And that's fine. You can just, because we didn't change this side, so we just know, hey, it's the same thing. A sub 1 parentheses negative 0.61051 over negative 0.1. And now what I'm going to do is divide these two values in my calculator. So divide by negative 0.01. Or 0.1, not 0.01. And I will get that 1258 equals a sub 1 times 6.1051. All right, not so bad, because now all I have to do is divide both sides by this 6.1051. So 1258 divided by, I get 206. So I'm getting 206.0572308 equals a sub 1. Now, all of this is pretty meaningless, right? Because we didn't have 5% of the person, right, show up. So we could just drop all of that and say there was about, because it's a word problem, it's real life, there was about 206 people on the first day. Maybe I should make a complete sentence here. There was about 206 people on the first day. And there we go. No problem at all. Just pull out the key parts and you're good to go.